So in this lecture now, I want to work through some classifications of glycosidic linkages, right? Remember that a glycoside is the carbohydrate term for an acetal or a ketal, where we're looking at this glycosidic linkage at the anomeric carbon. So the first step in identifying these is to find that carbon with a +2 oxidation state. And the glycosidic linkage is this oxygen-carbon bond here. I'll highlight it, that connects one sugar to the other in a disaccharide. So the stereochemistry of this oxygen or CO bond is cis to the primary alcohol, right? So this is going to be a beta anomeric form. And the numbering of this beta linkage is based on the numbering around the ring. So carbon 1 is the acetal here, or what was the aldose. And on the other ring, carbon 1, once again, is that anomeric carbon, what was the aldose. If I number around 1, 2, 3, 4, 5, 6, what I can see now is that my glycosidic linkage is between carbon 1 of the monosaccharide on the left and carbon 3 on the right. So this is a beta 1,3 glycosidic linkage. We'll do another example with one furanose and one pyranose. Finding the anomeric carbon in each first. The anomeric carbon that is participating in a glycosidic linkage is here. This is the acetal. Okay. The numbering on this furanose ring is 1 through 5. It's an aldopentose. The numbering on the other ring is 1 through 6. Okay, the stereochemistry is trans or alpha on the furanose ring, where we have the acetal. So this is an alpha 1,6 glycosidic linkage. Okay, and we know these glycosidic linkages are formed during the reaction between an alcohol and some sort of hemiacetal, right? And we've done those mechanisms previously. And upon addition of water and acid to these compounds, they will hydrolyze into monosaccharides, okay? So disaccharides and polysaccharides are connected through a series of glycosidic linkages or acetal type functionalities, and understanding whether they're alpha, beta, or 1,3, 1,4, 1,6, where 1,4 and 1,6 are the most common biologically, that's an important aspect for biochemistry, especially in glycogen synthesis and degradation. So for more practice with these glycosidic linkages and identifying the types, you can visit Unit 3 of my Orgo 2 course guide at chemguides.com.